Welcome, developers and AI architects. Let's get started. Today, we are unlocking the power of Claude Code's terminal interface by mastering advanced status line customization. We will learn how to extract real-time token usage, trace logic paths from transcripts, and build custom scripts that keep you fully informed. Let's dive in. Let's begin by defining what status line customization is. The status line is a persistent display at the bottom of your Claude Code terminal that can run arbitrary scripts to show live session data. The basics are incredibly straightforward. Claude Code pipes runtime information into your script via standard input, and whatever your script prints to standard output becomes your new status line. Why should you care? Because having real-time observability into your token usage, costs, and current logic paths is essential for professional agentic coding. How do you set it up? You simply update your /claude/settings.json file or use the built-in /statusline/ command. In our deep dive, it's fascinating to note that this architecture is language agnostic. Whether you prefer Python, Node.js, or Bash, as long as it handles standard input and output, you can build a highly customized display. Take a look at this flowchart, which illustrates the execution model. The Claude Code UI spawns your custom script as a subprocess. The script reads the JSON payload from standard input. It extracts exactly the data you care about, like tokens or costs. Finally, the script prints a formatted string to standard output, which triggers the green node, a real-time terminal display update. Let's explore the easiest way to build these displays, the /statusline command. What is this? It's a built-in shortcut that tells Claude to autonomously generate and configure the script for you. The basics involve typing /statusline followed by a natural language description of your desired UI. Why do it this way? Because writing JSON parsing scripts manually is tedious, and having the AI build its own interface extensions is a massive time saver. How do you invoke it? You can prompt /statusline. I want you to create a status line that displays the current used output style implemented in Python. Our deep dive reveals that this command actually spawns a specialized subagent. This agent securely navigates to your home directory, edits the settings.json file, writes the Python script to disk, and binds everything together seamlessly. This state diagram maps out the subagent's automated workflow. You start by typing the /statusline command. The system transitions to spawning a dedicated subagent. This agent branches into two concurrent tasks, updating the global configuration file and physically writing the implementation script to disk. Once both complete, the success state is reached, and your terminal updates immediately. To customize the display, we must understand the data we are working with, the JSON payload. What is this? It is the structured data that Claude Code pipes into your script's standard input on every single turn. The basics are that this payload is packed with metrics like your active model, context usage, cost, and the current output style. Why does this matter? Because this live session dictionary is the only way your script knows what is actually happening. How do you access it? In Python, you simply run json.load sys.stin. For our deep dive, the most powerful element in this payload isn't just the token counts, it's the transcript path key. This key points directly to the local sol file containing the entire chronological history of your current session, unlocking advanced logic tracking. Here is a conceptual class diagram representing the structure of the JSON payload you receive. Notice the fields available to you: output style, context usage for your tokens, costs, and importantly, the transcript path. By parsing this object via json.load, your script gains full access to all these vital session metrics. Now we move to implementation, writing the Python extraction script. What is this? It's the code that parses the payload and outputs your custom string. The basics require the script to execute quickly, grab the necessary keys, and print a single line to standard output. Why standard output? Because printing to stout is the strict mechanism required to feed text back into the Claude Code terminal engine. How do we do it? We use dictionary extraction like inputData.get, output style, and print the result. Look at the sample code. It's just a few lines to load the JSON and print a formatted string with your token counts and style. In our deep dive, a crucial engineering tip: this script runs synchronously on every single UI update. If you use bracket notation and hit a missing key, the exception will crash your status line. Always use safe.get methods with reliable fallback defaults. This sequence diagram maps the rapid execution cycle. The Claude Code UI passes the JSON payload to your script via stin. The script parses the JSON, safely extracts metrics like context usage, and returns the formatted token string via stout. Claude catches this output and immediately renders the fresh terminal display. Let's escalate our capabilities by tracking logic paths via transcripts. What does this mean? It means dynamically extracting the last user prompt or active tool call directly from the session's SOML transcript. The basics rely on utilizing that transcript path key we discovered earlier. Why do this? Real-time token counts are helpful, but when you are orchestrating long, autonomous AI loops, displaying the exact prompt the agent is currently working on keeps you perfectly oriented. How is it done? Your script opens the transcript file, parses the JSON objects, and filters for entries where the role is user. For our deep dive, efficiency is key. A robust implementation opens the file, splits the contents by line breaks, and iterates in reverse. This allows you to extract the most recent logic path instantly without wasting CPU cycles, scanning the entire conversational history. Let's trace the transcript parsing logic. We start by reading the transcript path and verifying the file exists. If yes, we read and split the file by new lines. We iterate through the lines in reverse order, checking if the role equals user. The moment we hit a match, we hit our blue node, we extract the message content and immediately display that logic path in the UI, ensuring peak efficiency. Let's apply this to a real-time use case, the DevOps observability display. The scenario: a DevOps engineer is running multiple parallel Claude Code sessions, using different output styles to deploy complex microservices. The problem is that with so many terminals, they lose track of which agent is doing what, and scrolling through massive logs wastes time. The execution: they implement our custom script. It reads the output style from STIN, grabs the token usage, and parses the transcript path for the last active prompt. The outcome is a beautiful, dynamic status line that reads, YAML style, last task, deploy auth service tokens, 45K. The value here is immense. The engineer gains instant, at-a-glance situational awareness across all their workspaces, tracking exact logic paths and monitoring token budgets perfectly without ever breaking their flow. This journey map highlights the seamless developer experience. During setup, the user simply invokes the /status line command, and Claude's subagent generates the script. During execution, the user runs parallel agents while the Claude engine injects the live JSON payload. Finally, in the output phase, the Python script rapidly extracts the transcript data and renders the real-time display directly to the terminal UI. To build production-grade tools, we must focus on advanced error handling and resilience. What does this entail? It means fortifying your status line script against missing files, corrupted JSON, or empty payloads. The basics are simple but mandatory. Always wrap your file input, output, and JSON parsing in try/except blocks. Why is this so critical? Because on the very first turn of a new session, the transcript file might not exist yet. If your script throws an unhandled exception looking for it, your entire terminal display crashes. How do we prevent this? Add explicit checks like if not os.path.exists, transcript path, return no transcript. In our deep dive, you should also check for empty content before attempting to split lines. By consistently returning a safe fallback string when data is missing, you guarantee your UI remains perfectly stable, even during unpredictable initialization phases. Examine this error handling flowchart. The script enters a try block and attempts to parse the STIN JSON and open the transcript file. If an exception is caught, or if the file is missing, the flow routes immediately to the red node, return a safe fallback string. This bypasses crashes. Only when all operations succeed does it reach the green node to return the extracted logic path. Let's wrap up with best practices for scaling your workflow. First, keep your scripts fast. The status line updates synchronously. If you add heavy network calls to your script, your terminal will lag. Second, centralize your configuration. Store scripts like statusline.py in your global /.claude/ directory to keep your environment clean and organized. Third, use subagents for setup. Never write the boilerplate yourself when the /statusline command can autonomously generate the Python extraction code for you. Finally, version control these scripts. A highly optimized observability display is a massive asset. Commit it to Git and share it across your engineering team. I invite all learners to like, subscribe, and visit quicktechie.com for premium certification prep, including massive Q&A banks, full ebooks, audiobooks, full-length training courses, and expert interview guides. Thank you for watching. Our final mind map synthesizes status line mastery. We prioritize performance by keeping scripts lightweight and avoiding network calls. We maintain organization by centralizing files in the .claude directory and using version control. We leverage automation by allowing the /statusline subagent to generate our boilerplate code. Finally, we ensure resilience by always handling missing files and using safe dictionary defaults. Master these pillars, and your workspace will be unstoppable.